So in this video, we're going to talk about how to solve logarithms. So we have this property, which we call the equality property. It's also known as the one-to-one property of logarithms. So it tells us that if the log base b of x equals the log base b of y, that x equals y. Notice that the bases of both logarithms must be the same. Remember also the definition of a logarithmic equation. The log base b of a equals x if and only if b to the x equals a. Remember, this is true for all positive numbers a and b. So this value right here, this a has to be positive because the reason is if we exponentiate something, like if we have b to the x, then we're going to get a that's a positive number. So that's important to remember that a and b are both positive numbers. So that's something to keep in mind when we work on solving these equations and checking the reasonableness of our solutions. So let's start off by finding the solution of the natural log of 2x minus 1 equals the natural log of 3x plus 4. So we have the same base, so we can go ahead and set 2x minus 1 equal to 3x plus 4. So now we just need to solve this equation, which I'm going to do by moving all my variables to one side. So this 3x, I'm going to subtract 3x from both sides. So that gives me negative 1x minus 1 equals 4. So now what we do is we're going to add 1 to both sides. And when we do that, we get negative 1x equals 5. Now to solve for x, we're going to go ahead and divide both sides by negative 1. And so that gives us x equals negative 5. We want to check if this is a reasonable solution by plugging back into our original equation. So we have the natural log of 2 times negative 5, which is negative 10, minus 1, equals the natural log of 3 times negative 5, which is negative 15, plus 4. So that says that we have the natural log of negative 11 equals the natural log of negative 11. Well, we can't take the natural log of a negative number, right? Because it says all positive numbers a and b. So since a is negative in both of these natural logs, this is going to be an extraneous solution. So actually we will have no solution to this equation because we only found one solution, and that was an extraneous one. So now you can pause the video and try this example on your own. So here we have two logs of the same base that are set equal to each other. So we can say that 2x minus 1 equals x plus 4, and then we can solve for x. We get x equals 5, and when we plug that back in, we get the log base 6 of 9 equals the log base 6 of 9, which is a reasonable solution. So now let's solve the log base 3 of x plus 2 equals the log base 3 of x squared plus 4x minus 2. So we have two logs of the same base, so we're going to say that x plus 2 equals x squared plus 4x minus 2. So notice that this is a quadratic equation. When we have a quadratic, we want to set it equal to 0, right? Ax squared plus bx plus c equals 0 so that we can solve. So I'm going to go ahead and subtract x and 2 from both sides of my equation. Remember, when I do that, I can only combine like terms, right? So here everything cancels, so I have 0. But then x squared is going to stay by itself because only the 4x and the minus x can combine, right? Because those are like terms. So we have plus 3x, and then minus 2 is minus 4. Now I'm going to solve this by factoring. So I'm going to take this negative 4. I need two numbers that multiply to negative 4. So let's list out the factors of 4. They're 1 and 4 and 2 and 2. Now let's think about the signs. 4 is negative, so I need a positive and a negative factor. 3 is positive, so that tells me that my bigger factor is going to be positive. So I'm going to make the smaller factors negative, and then I'm going to add up each of these factor pairs. So negative 1 and 4 is 3, so that is my correct combination. So I have 0 equals x minus 1 times x plus 4. Now what I can do is I can set each of these equal to 0 and solve for x. So I have x minus 1 equals 0 and x plus 4 equals 0. X minus 1 equals 0, I can solve by adding 1 to both sides, so that gives me x equals 1. X plus 4 equals 0, I can solve by subtracting 4 from both sides, which gives me x equals negative 4. So what I can do now is check that both of these solutions are reasonable by plugging back into the original equation. So when I do that, I get the log base 3. Let's first plug in x equals 1. So I get the log base 3 of 1 plus 2 equals the log base 3 of 1 squared, which is 1, plus 4 times 1, which is 4, minus 2. So I have the log base 3 of 1 plus 2, which is 3, equals the log base 3 of 1 plus 4, which is 5. 5 minus 2 is 3, so that does work out. Now let's plug in x equals negative 4. So we have the log base 3 of negative 4 plus 2 equals the log base 3 of negative 4 squared, which is 16, plus 4 times negative 4, so that's negative 16, and then minus 2. And that tells us the log base 3 of negative 2 equals the log base 3 of negative 2. Since we can't take the log of a negative number, this is going to be an extraneous solution. So x equals 1 is going to be the only solution that works for this equation. Now let's find the solution of the natural log of x minus the natural log of x minus 3 equals the natural log of 7. So what we want to do is we want to use those properties to first simplify this equation. So notice that I can use the quotient property. So I can say that this is the natural log of x over x minus 3 equals the natural log of 7, right? We have two logs with the same base, so we can go ahead and say that x over x minus 3 equals 7. And I'm going to set this up as a proportion, so I'm going to put this 7 over 1. So I'm going to go ahead and cross multiply. And when I do that, I get 7 times x minus 3 equals 1 times x, which is x. So I'm going to go ahead and distribute this 7. So I have 7x minus 21 equals x. And now I'm going to subtract x from both sides to work on solving for x. So that gives me 7x minus x, which is 6x minus 21 equals 0. Now I'm going to add 21 to both sides. So when I do that, I get 6x equals 21. So 6x equals 21, I can solve for x by dividing both sides by 6. And so that gives me x equals, well, 21 and 6 can be reduced, right? Both are divisible by 3. So we have 7 and we have 2. So x equals 7 over 2. We just want to make sure and plug into our original equation so that we're not taking the log of any negative numbers. So we have the natural log of 7 over 2 minus the natural log of 7 over 2 minus 3 equals the natural log of 7. So that tells us the natural log of 3.5 minus the natural log of 0.5 equals the natural log of 7. And actually, we can kind of simplify this using the quotient property, right? This is the natural log of 3.5 divided by 0.5. And that does, in fact, equal the natural log of 7, right? If you do 3.5 divided by 0.5, that tells you the natural log of 7 equals the natural log of 7. So now you can pause the video and try this example on your own. So since we have the log base 3 of 2x plus 1 minus the log base 3 of 2x, we can go ahead and combine them using the quotient property. So that tells us that 2x plus 1 over 2x equals 9 over 1. Then we cross multiply and we get 18x equals 2x plus 1. So when we solve this equation for x, we get 1 over 16. And if we go back to our original logs and plug in 1 over 16, we get the log base 3 of 2 times 1 over 16, so that's 1/8 plus 1, minus the log base 3 of 2 times 1 over 16, so that's 1 over 8, and that equals the log base 3 of 9. So we don't have any negative numbers there in the logs, so x equals 1 over 16 is a good solution. So now let's find the solution of the log base 2 of x minus 7 plus the log base 2 of x equals 3. So I'm going to go ahead and condense the left side using the product property. So I have the log base 2 of x times x minus 7 equals 3. So I'm going to go ahead and distribute here on the left. So I have the log base 2 of x times x is x squared minus 7 times x is 7x, and that equals 3. Well, now to solve this equation, I'm going to use the exponential form, right? I'm going to do 2 to the third equals x squared minus 7x. Okay, so I have 2 to the third equals x squared minus 7x. 2 to the third I can just do on my calculator, so that's 2 caret 3, so that equals 8. So I have 8 equals x squared minus 7x. Once again, this is a quadratic, so I need to set it equal to 0. So I'm going to subtract 8 from both sides. On the left side, that leaves me with 0, so I have 0 equals x squared minus 7x minus 8. So I'm going to work on solving this here. So I have 0 equals x squared minus 7x minus 8. So I'm going to look at this final term. I have negative 8. Okay, I need two factors of negative 8 that are going to add up to negative 7. Since 8 is negative, I need a positive and a negative factor. Since 7 is negative, that's going to make my bigger factor negative. So the factors of 8 are 1 and 8 and 2 and 4. So if we make the bigger factor negative and we add these together, here we get negative 7. 2 and negative 4 gives us negative 2. So the correct combination is 1 and -8. So this tells us that 0 equals x plus 1 times x minus 8. So now we can set each of these equal to 0, and we can solve for x. So we have x minus 8 equals 0 and x plus 1 equals 0. So now we subtract 1 from both sides, and that gives us x equals -1. Here we add 8 to both sides, and that gives us x equals 8. So now let's plug back into our original equation, right? We have the log base 2 of x minus 7 plus the log base 2 of x equals 3. So let's plug in x equals -1. Well, we get the log base 2 of -1 minus 7, which is -8, plus the log base 2 of -1 equals 3. So we have negatives there in our logs, so x equals -1 is not a good solution to use. Let's try x equals 8. That gives us the log base 2 of 8 minus 7, which is 1, plus the log base 2 of 8 equals 3. And so those are good, right? Those are all positive numbers, so x equals 8 is the only solution that we can use. X equals -1 is an extraneous solution. So now you can pause the video and try this example on your own. So in this one, I want to use log properties to condense down this equation. But since I have a log on both sides, I'm going to move them all to one side. So since this is a minus log base 3 of x, I'm going to add the log base 3 of x to both sides. So I have the log base 3 of x minus 6 plus the log base 3 of x equals 3. Now I can condense them using the product property, which gives me the log base 3 of x squared minus 6x equals 3. So now I can rewrite this in exponential form, which gives me 3 cubed equals x squared minus 6x. So that's 27 equals x squared minus 6x. So when I solve that quadratic equation, it gives me two solutions. I have x equals -3, x equals 9. If I plug back into the original log, plugging in x equals -3 gives me some negative values, so it won't work. So x equals 9 is the only solution that I can use. So remember that you can use the properties of logarithms to simplify and solve equations.